Okay, class, I'm going to go over your study guide for your next test on polar coordinates and rectangular coordinates. We need to know how to go from a rectangular coordinate or an XY coordinate to a polar coordinate and then vice versa. We need to know how to go from a polar coordinate to a rectangular coordinate. So I'm going to go over each of these questions. You can use notes on your test. So all I'm going to do is just change the coordinates, and there'll be 10 questions that you'll have to answer on short answer. All right, so let's start with number 1. So on 1 through 5, we're given XY coordinates, and we have to go to a polar coordinate. So 2 of these I see are unit circle coordinates. Actually, 4 of them are. Anyway, if you see these root 2 over 2s or root 3 over 2, I'll go ahead and say if you have if the x and y is the exact same value, that's going to be one of your pi over 4, just depending on what quadrant it's in, because that's a 45, 45, 90 triangle. 45 degrees is pi over 4. Or number 4 would be negative positive, and that would be in the second quadrant. So anyway, we'll look at those when we get there. So number 1, this is XY coordinate negative root 2 over 2 comma root 2 over 2. That's straight off the unit circle. So on the unit circle, that is right in the middle here. Okay, so straight off the unit circle, we know the radius is 1. And so on these polar coordinates, we're writing 1. We're writing our radius first, and then we'll write what the radian is, the positive radian. So the positive radian is 3 pi over 4. So that is your answer on number 1. Okay. Number 2, that you see this root 3 over 2, and root 3 over 2 is being multiplied by 5. That tells me what the radius is, because on the unit circle the radius is 1, but if we multiply it by 5, then that means the radius is 5. Or this was negative 1/2 negative 1/2 times 5. So we're just taking the coordinate root 3 over 2, negative 1/2, and we're multiplying that by 5. So my radius is 5. And we are at, this is a positive negative. So just if you look on the unit circle, positive root 3 over 2, negative 1/2, what is the radian at that spot? And that is 11 pi over 6. Okay. So let's erase this and do number 3. Okay. All right, number 3. When you have x and y values that are the exact same, that's 45, 45, 90 special right triangles. This is positive, positive, so we're in the first quadrant. So if you remember on the 45, 45, 90s, whatever your leg length is, the hypotenuse, or the radius in this case, is that leg length times root 2. So my radius on number 3 is 7 root 2. Okay. So now we just need to figure out the radian. And the radian, it's right in the middle of your first quadrant. That's pi over 4. Radian. Okay. What about number 4? Number 4, we have the same x and y, just different signs. So this is a negative positive. So we're going to be right in the middle on our second quadrant. And so you got negative root 13, positive root 13. Well, your hypotenuse is your leg length times root 2. So root 13 times root 2, that's just root 26. So there's my radius, is root 26. And my radian is going to be 3 pi over 4. Okay. So now let's do number 5. So this one is not on the unit circle. So we need to plot it. It's negative 7, positive 24. So we are going to be in the second quadrant, negative 7, 24. So we, well, if you'll notice, this is a triple. This is a right triangle triple. And you need to know these these right triangle triples. You might see, you probably will see a different one on your test. 5, 12, 13, 8, 15, 17, 7, 24, 25. Any multiples of these also, like a 6, 8, 10 is just a 3, 4, 5 times 2. So this is a 7, 24, 25. There's my radius, 25. All right, so now we got to figure out what the radian is. So what we're going to do is first figure out the degree. I know this is somewhere between 90 degrees and 180 degrees. We just got to figure out exactly where. Well, first thing we're going to do is figure out what is the degree in here. And so we're going to use our inverse trig functions. Any one you want to use. We have all three sides of the triangle. You can do sine inverse, cosine inverse, tangent inverse. If we did sine inverse, that would be 24 over 25. This is going to give me this exact degree in the triangle. So once I get that, then I can figure out exactly where between 90 and 180 this coordinate's going to be. Okay, so in my calculator, I'm going to do second and sine. That gives me sine inverse, and I'm going to do 24 divided by 25. Okay, so inside that triangle is 73.7 degrees. Okay, so to figure out what exactly the degree is from here to here, we could just do 180 minus that. 180 degrees minus that 73.7. Minus 73.7. So the degree, I get 106.3 degrees. Okay, but remember on the directions it wants where theta is between 0 and 2 pi or or a decimal between 0 and 6.28. So to change a degree to a radian, all we're going to do is do our degree that we get times pi over 180. Well, let pi be 3.14. And simplify this, and then that's going to be my radian. So 106.3 degrees times 3.14 divided by 180. So my radian, I get 1.85. Okay. And that would make sense, because if you start on the x-axis at 0 radians. Well, at pi is just 3.14. Well, half of that is 1.57. So your decimal needs to be somewhere between 3.14 and 1.57. So this makes sense. So that is my polar coordinate for number 5.